Hi, today we're going to discuss how to solve the absolute value inequalities. Now, I've got to warn you that they're a little tricky, so you might want to celebrate afterwards. Now, there's a couple different situations involving these that we need to look at, and here is going to be the first one. I'll start out with a simple example. The absolute value of x less than 2. Now, let's see what happens in this situation. Let's put in values for x. For instance, let's put in 2. The absolute value of 2 is 2, and 2 is not less than 2. So that doesn't work. So let's put in a 1 for x, and we'll get absolute value 1, that equals 1, that is less than 2. We put in 0, that's okay. Now let's try the absolute value of negative 1. That's 1, which is less than 2. Absolute value of negative 2, that won't work. So there seems to be sort of a boundary region here that's going to work between 2 and values of x that are between 2 and negative 2. So we get x is between negative 2 and 2. So let's look at a little more difficult problem here. What we're going to do is have a boundary value between 1 and negative 1 instead of 2 and negative 2 like we had in the last case there. So here's what this situation looks like, and we've solved these inequalities before. So we're going to add 5 to each section so we can get x in the middle by itself there, and it works out, and x is between 4 and 6, including 4 and 6. Now let's take a look at the other situation where we have a number that's less than an absolute value. Let's start out the same way. Let's substitute in some values here, and let's see what happens here. Let's put in 2 again for x. We know that that won't work because 2 is not greater than 2. Let's put in 3. 3 will work. 4 will work. 5 will work. 5 is greater than 2. Now let's put in some negative values and see what happens. Okay? So we get put in a negative 2. Take the absolute value of negative 2 is 2. That's not greater than 2, so that won't work. And put in negative 3. That will work. 3 is greater than 2. Negative 4, negative 5, they all work. Okay, so it seems like we've got to get x values that are greater than 2 or x values that are less than negative 2 to make this work. This is sort of a union situation. Okay, so let's look at a more complicated example of this. So we're going to come out with 2 inequalities that we have to work out, separated by, our answer is going to be separated by an or in the end. Okay, let's do x plus 1 is greater than 2, and then we'll have to do x plus 1 is less than negative 2. So let's just work this side, and we subtract 1 from both sides, and we get x is greater than 1. Let's do x plus 1 is less than negative 2. So we go ahead and we'll subtract 1 from both sides, and we'll get, for the rest of our answer, x is less than negative 3. So x is greater than 1 or x is less than negative 3 is our solution set. Let's take a look at this one here. Now, this is something less, the absolute value less than a number, so we're going to have boundary values. In this case, it's going to be 5 and negative 5. Go ahead and work it like a regular inequality. When we get x in the middle, we're going to subtract 1 from both sides, from each section, and we'll get 2x is between negative 6 and 4. We're going to divide through by 2, and we should get x is between negative 3 and 2 for our solution set. Alright, in our next problem, this is the situation where we got the absolute value greater than some number, so we're going to have 2 inequalities that we're going to have to work. And we're going to have those things that are greater than 12 and less than negative 12. So we set up our two inequalities. Let's work the left-hand side first, and we're subtracting 2 from both sides. If 5x is greater than 10, divide through by 5, and we get x is greater than 2. That's half our answer. Now, let's go to the other side, subtract 2, and we'll work that down, and we'll get 5x is less than negative 14. Divide through by 5, and we'll get x is x is less than negative 14/5. That's the rest of our answer. Okay, let's see what we got next here. Oh, this is going to be an application type problem. Let's suppose that a bird wants to build a nest that is 10 inches in diameter, and let's say he can build a perfect nest, but he doesn't mind being off 1.5 inches either way. So what we can do is set up an absolute value inequality that represents this situation. So let's build this up here. So he'd be satisfied with a nest that was 8.5 inches, just subtract 1.5 from 10. Or he would be satisfied with a nest that was 11.5 inches, which would be 1.5 inches added on to the 10 inches. So let's see what an absolute value inequality would be that would show this situation. So here's what it looks like. The absolute value of d minus 10 is less than or equal to negative 1.5. So this is a situation where we have the boundary values between 1.5 and negative 1.5. And so we'll work that down. We'll add 10 to each section here, and we should come out with the diameter being between 8.5 and 11.5, but including 8.5 and 11.5. Or you could say 10 plus or minus 1.5. Bye.